We are super excited to be here today with Dr. Rosane Oliveira. Now, Dr. Rosane Oliveira is the founding director of the UC Davis Integrative Medicine Program. She has over 20 years of scientific experience in genetic research. She writes about health and nutrition every week on the program's blog, and she teaches lifestyle medicine to medical students and residents at UC Davis. Thank you so much for being here with us today, Dr. Oliveira.
Hello, my pleasure. Glad to be here.
Fantastic. So you have a wealth of experience about a lot of different topics. So we're going to start with diabetes, and then we can delve into other topics from there. But first question for you is, in the research studies that you've read and that you've personally conducted, can you give a little insight into our listeners about what is insulin resistance and what actually causes it in the first place?
All right. So, insulin resistance is when the body produces insulin, but the cells are not seeing that insulin is around. So basically, you have insulin around, but the cells don't recognize its presence. So the cell is resistant to it, so it doesn't respond. Why is that? Because insulin is like a key, right? So there's a keyhole, insulin goes in there, and then once it goes into the receptor, it opens a door. So when you're insulin resistant, what happens is you have the key, you have the keyhole, but the key doesn't go in, so there's no way for you to open the door. So that's insulin resistance. And the hypothesis nowadays is that what prevents insulin, the key, from going into the keyhole is actually the amount of fat in the diet, meaning it's a common misconception to blame carbohydrates, even though refined carbohydrates add to the problem. But the idea is that the more fat we have, the more the receptor cannot see the insulin. So the more the keyhole is locked to the insulin to go in there. So it is a factor of how much fat, specifically how much saturated fat we have in the diet. And the more we have, the less insulin works, the more resistance we have, and the higher the chances then to develop metabolic syndrome, become pre-diabetic, and eventually get to develop full-blown type 2 diabetes.
Okay, this is great. So can you speak to the confusion surrounding fat and ketogenic diets? You're saying, fat's the problem, and yet there's lots of experts, lots of books saying, no, it's actually the solution. You can follow a ketogenic diet and get amazing results. Can you speak to that confusion?
Yes. Well, it's probably going to be a very long answer. So when we speak about type 2 diabetes, that's one thing that we all need to understand. And type 2 diabetes is related to excess calorie in the diet and excess body fat. So anything we do that will decrease the amount of calories in the diet or decrease the amount of body fat in the diet will cause type 2 diabetes to be reversed. So the biggest problem is this, because if you think about it, if you go on any diet, you're likely going to increase the amount of calories you eat, correct? And if you go on any diet, you'll likely also decrease the amount of body fat you have in your body because you will lose weight. So the biggest problem is that anytime you decrease calorie consumption, anytime you lose weight, type 2 diabetes will be reversed, no matter what diet. So this is true. So if you're looking at very specifically, is there a diet that is better for you to lose weight or reverse diabetes? If you don't understand the science very, in a profound way, any diet can do. Atkins can reverse type 2 diabetes. Ketogenic diet can reverse type 2 diabetes. Going on fast reverses diabetes. We all know that, right? Plant-based diet will reverse. Mediterranean diet can reverse diabetes. So that's, I think, the biggest, I don't like to say problem, because it's not a problem. If you're losing weight and type 2 diabetes is being reversed, shouldn't be a problem. But here's the thing. If we think about calories or energy consumption, if we compare fat, protein, and carbohydrates, 1 gram of each one of the micronutrients. Fat is the one that is going to have the highest amount of calories, right? It's the most energy dense, the ones that has the most energy. So if you're thinking about that, any diet that reduces the amount of calories will have a chance to reverse type 2 diabetes. The diet that decreases the amount of fat will decrease the calories the most, correct? So that's a given. So that's 1 point for fat in that sense. But of course, when we talk about low carb diets, or ketogenic is one of them, what happens is they're not cutting carbohydrates. They believe they're cutting carbohydrates, but there are carbohydrates in every vegetable they eat, correct? In the ketogenic diets, there are carbohydrates, anything that is not meat that they allow themselves to eat in a ketogenic diet will have carbohydrates. What they're eliminating from the diet are the high calorie foods. They are usually very low in nutrient density, but very high in calorie. So if they eliminate the bread, and if they eliminate the white pasta, or if they eliminate desserts, right? So they are indirectly also decreasing the amount of calories they eat. So ketogenic diet works because of 3 things. 1, you will decrease the amount of calories you're eating, no matter what. If you're removing all the high calorie or high energy dense foods that are a big mix of both fat and carbohydrates that do not provide fiber, right? So they're eliminating that, so they will consume less energy, they will consume less calories. And so that's one of the reasons. Reason number 2 is people will be losing weight. If you lose weight, no matter what, your type 2 diabetes will be reversed, okay? And the third reason that happens, and I believe we discussed this last year, but I can talk about it this year again, because I'm sure different people are gonna watch this year, or if someone watched last year, we'll have a refresher. It's what I like to call the sink analogy, correct? So the sink analogy goes like this. So let's say anything you eat that has glucose is like the water that comes out of your tap in your sink. And then the water that's being collected in the sink would be the equivalent of glucose being in your bloodstream. Okay, so you eat, you open a tap, glucose comes down, but what happens when you stop eating, you close the tap, water stops being accumulated and it's gonna flow right through the drain. No problem there. Let's say you eat a lot of refined carbohydrates, right? Or stripped carbohydrates without the fiber. It will be the equivalent of you opening 2 taps at the same time, okay? So you have massive amounts of glucose that are coming in the bloodstream, which is your sink, but it's still, you close the tap, both, and that accumulated glucose or the accumulated water will go through the drain. Beautiful. Now, let's say you brush your hair on top of the sink, and now your hair accumulates in the drain. You open 1 tap. You don't even need to open the whole tap, just a little bit. The water will accumulate when you stop eating. It may continue to be in your sink and not go through the drain. Why? Because the hair is there. So the hair would be the equivalent of the fat in the diet. So when someone goes on a diet, let it be Atkins or ketogenic, I don't want to pick on ketogenic, but anyone that will be eliminating carbohydrates or high density carbohydrate rich foods, what's going to happen is that they are refusing to turn the tap on. So no water is going to come on, or the amount is going to be so small because they do keep, I don't know if it's 10 grams or 10%. So, but the amount is so small that it doesn't really accumulate. So you have a sink that looks beautiful, which is the bodies that we see people in the ketogenic diet. They lose weight, they look great outside, right? Will be the equivalent of having a sink that is beautiful. Anybody comes in and they say, looks great, but the sink is not functional. The drain is clogged. So the sensible thing to do would be to remove the hair or to remove the excess fat in the diet. So it is exactly the same thing. And I believe the other biggest misconception that people have is believing that when they're eliminating carbohydrate from the diet, they're eliminating just carbohydrates, but they're not. Most often than not, they're eliminating excess fat as well. So like if you talk about cookies, right? I had a friend who said, oh, my doctor thinks I'm pre-diabetic. I have to stop eating cookies. Then I asked her, do you know that 50% of the calories in a cookie comes from fat? No. Of course, we have the white flour, we may have the sugar, but we also have chocolate chips, and we have massive amounts of either butter or oil. So we are removing fat when we're removing carbohydrates. They say, don't touch the potato, right? Don't eat potato chips or any potato. But usually the potato you eat, how do you eat? You eat it with olive oil, or you add butter, or you add cheese. So whenever you are eliminating carbohydrate, you're also eliminating fat. And that's why that's one of the things I ask people to pay attention to. And I give another example. I have someone in my family who wanted to lose weight. And then he told me, in the past, the only way I could lose weight is if I went into an Atkins diet. It's not a ketogenic. Atkins is different. And there's another problem we can discuss later on is most people in the plant-based community put the two together. Even though they're both low in carbohydrates, Atkins is high in protein and high in fat, but ketogenic is high only in fat, not in protein. In that sense, they know better. In that sense alone. But, and we can discuss this later if you want, but then this person in my family said, okay, I have to go on an Atkins diet. And I say, okay, what would you have to do to go on an Atkins diet? And he said, I have to stop eating the popcorn, the sugar popcorn that I like. I'll say, okay. And I have to stop eating potato chips. And I have to, I don't remember what the third thing was. It was something with bread, but also had oil. And I say, how about you eliminate all three things that you're going to eliminate with Atkins? You eliminate the potato chips, you eliminate the sugary popcorn, and the third thing I cannot remember. But instead, I want you to eat potatoes, plain potatoes for breakfast every single day. And I wanted to eat beans for lunch every single day. And he did that. And in a month, he lost like 10, 15 pounds because he's a guy. It's an unfair comparison. So it was a woman, right? So it's really not the potato. It's really, he's eliminating the carbohydrate, but the fat went along. So I told you it was going to be a long answer.
Sure, no, that was a terrific answer, and that was a great story, but your analogy with the sink is really brilliant. I hope that makes a lot of sense to people. So how quickly does insulin resistance develop, and how long does it take to reverse the disease following a low-fat, plant-based whole food diet?
Oh, it's very, very quick. You can develop insulin resistance within 3 hours of a fatty meal. It's that quick. So you eat high fat, and probably about 140-minute mark, the muscle cells stop taking up glucose as much. You start having glucose being in excess. So it's that quick. Of course, but then after another 3 hours that you had your meal, then insulin goes back to being normal and the body continues to respond. The problem that we have nowadays is that you eat your breakfast and it's high fat. It takes 3 hours, it takes you to insulin resistance. And when the body's starting to recover, you come in and you eat lunch, again, another meal with high fat. Then the body starts to respond, then comes dinner. Then you reach that phase again where the body is in an insulin resistant state. Then you go to your late evening snack. Then you go to bed, and the next day you start the cycle again. So you're never out of the cycle. And what starts happening if this continues to go for a long time, which is what happens, that's called the standard American diet, fat start being accumulated in the muscle cells. And that's what we'll discuss before. And then when cells and then the muscle cells, then the amount of time that it takes for you to get there is quicker, or you may start your day in a point that you're already insulin resistant, and or not you, your whole body, but at least your muscle cells are insulin resistant. And then you eat more fat. Fat continues to be accumulated in the muscle cells, and insulin resistance continue to rise up. Then this will be like the first stage. You're not type 2 diabetic. You don't even know you're insulin resistant at this point. You may get a blood test and insulin may look normal, but you continue to eat fat. You continue to be insulin resistant, or at least your muscles are insulin resistant, and comes to a point where the fat just cannot be accumulated in the muscle cells anymore. So next stage, they start being accumulated in your liver. So the liver has this function. Many people that are watching us today may not know that, but the liver is the one organ that keeps our glucose levels constant throughout the day. Otherwise, we would have to be eating 24/7. We couldn't even sleep because we wouldn't be able to keep anything going because we wouldn't have glucose. So we eat, then what is it that our muscles take up glucose, and then the liver takes up the rest and then stores for later use. Then between meals, as we need glucose, the liver starts dumping a little bit, takes from the storage and it starts delivering. Once the muscle cells have a lot of fat and the liver has a lot of fat, what starts happening is the liver now is insulin resistant. It cannot respond to the insulin. And then it never receives the signal that I'm eating now, insulin is going up, I don't have to release glucose anymore. And then we eat, we have high glucose, but the liver is constantly also releasing glucose. So it's glucose on top of glucose. That's when we start seeing high blood sugar. It's when we already have a lot of fat in the muscles, and usually we already have accumulation of fat in the liver, okay? But it continues because the liver is not supposed to be a fatty organ, right? So non-alcoholic fatty liver disease is a fatty liver. So not only will be releasing glucose in a constant way, we'll be trying to dump excess fat back into the bloodstream because we want to get rid of it. Then you start seeing increase of fats also in the blood, whether it be triglycerides or cholesterol would be more a matter of amount of saturated fat, but still, if you're accumulating fat, you were dumping back in the bloodstream. It shouldn't be happening. And the third stage would be when this accumulation of fat will reach the pancreas. So the pancreas all along, ever since the muscles start accumulating fat, has been increasing insulin production. Then the liver start being insulin resistant. Then the pancreas has to produce even more insulin to get rid of the amount of glucose, right? That is not entering the muscle cells and that is being constantly coming from the liver until the pancreas said, I've had enough. I just cannot produce more. Then you start having also fat accumulation in the pancreas. Beta cells start to die. And that's when you develop type 2 diabetes. From the beginning of just eating fatty meals 3-4 times a day, all the way into you were diagnosed with type 2 diabetes, it may take 10 years, 12 years. And that's why it's very hard for people to stop, put a break, and learn ahead of time. But the beautiful thing is that, like you said, it is very reversible and is super, super quick. There was a study done many years ago where they put people on, so there was a control group where people continued to eat their diet. Everybody that came in the study already had type 2 diabetes. Some people were already injecting insulin for 2 decades. So they're like stable type 2 diabetics. And the intervention group was this group where they were asked to eat high carbohydrate, high fiber diet, meaning you're eating carbohydrate, but carbohydrate, intact carbohydrate, carbohydrate that have fiber in it, which means you're not eating refined foods or packaged foods in most time. And the intervention group was asked to eat as many calories or as much carbohydrate with fiber as possible so they would not lose weight. Remember when we started this conversation, say if you lose weight, type 2 diabetes will be reversed. So this group, they said, no, we do not want you to lose weight. We want you to keep your weight stable. We just want you to eat more carbohydrates with more fiber. That's what they did. And what happened is that 50% of the type 2 diabetics were able to completely stop injecting insulin. And that happened in 16 days, 2 weeks. So it's super fast. The body is very resilient. And of course, like we said, if you lose weight, it will reverse. But even if you do not lose weight, and even if you do not cut calories in your diet, if you focus on carbohydrates that have fiber attached to it, you can see the same reversal. And that's the beautiful thing about a whole food plant-based diet. Like you can see the results even if you do not lose weight, and even if you do not cut calories. Of course, if you're eating more whole plant foods, indirectly, you will probably eat less calories because it's almost like impossible for you to eat enough to gain weight, but you can eat enough to keep your weight stable.
So I know the exact study that you're talking about. This 1972 James W. Anderson, Kylene Ward, where they basically, made sure that people were not losing any weight at all. And I think it was actually, when I read that study, my mind was blown because I, up until that point, thought that weight loss was mandatory in order to reverse insulin resistance and reverse type 2 diabetes. But just like you're saying, it's helpful, but it's not required. And so one of the things that you're actually really, you're very well researched in is understanding how your lifestyle factors can affect your gene expression. So can you give us a little bit of insight here into what it means to turn genes on and turn genes off? How does that actually happen?
Yes. Well, before I answer that, I just want to go back to what we were just talking about. This study was not the only one that did this, where people were asked to change the diet and keep their calorie intake the same. There was prospective study that I think many people in this community knows about. It was the Adventist Health Study that followed people that were, 7-day Adventists who were in a range of being completely plant-based or being pescatarians or being vegetarians, all the way to eating a certain amount of meat. What they all have in common is they do not have alcohol and tobacco use most of the times, I would think. But there was this degree of how much animal products they had in their diet. And they follow about 89,000 people over the course of 50 years. And they saw that if you compare the people that only ate plants versus the ones that would have animal foods, the ones that ate animal foods were 75% more likely to have specifically type 2 diabetes, even when they were matched for weight. So it's another way of seeing. So it was not an interventional study, it was a prospective longitudinal study, but it was the same. And then just going outside of the US, they did a similar study with Buddhist monks, and they saw the same thing. There were the monks, they were 100% plant-based, no animal foods, and the ones that would have a little bit of meat, which is sometimes a lot of people ask me, but not just a little bit? And I say, so the comparison that they made was, so among the men who ate meat, they ate about 8% of what Americans eat. So it was nothing, it was less than 10%. And women ate about 3% of what is the American intake of meat. And what they saw at the end of the study was also a prospective study, is that compared to those that had no animal foods, the men were 75% more likely to develop type 2 diabetes, and the women 50% more. So just a little bit is enough. So now I'm going to answer your question about genes. Perfect. I just wanted to make that clear because it's not just interventional studies. We see that across many different types of epidemiological studies. Even if it's just observational, we can see that in longitudinal studies as well. And it's very specific to type 2 diabetes. In all cases, the weight is the same when they compare people. So it's really not the weight, even though losing weight will reverse type 2 diabetes, as we discussed before. Okay, about lifestyle and genes. Where should I start? So we're talking about obesity and type 2 diabetes. So when I'm going to talk about two different genes, FTO and PPAR gamma. So FTO is fat and obesity, fat mass and obesity associated gene. And it's the one well-known marker that if you have a mutation in one of your two genes, the two copies that you have, or if you have two mutations, it means that you're more likely to have higher BMI, and you're also more likely to develop type 2 diabetes. I'm talking specifically about FTO. And studies done in the past, I would say, I think in the past 3 to 5 years, really show how the food we eat have a massive effect on FTO. Up until that point, people think, oh, I lucked out. You know, I have the two copies, so FTO is something, it's my fate. You know, I have a higher likelihood of having high BMI. But what this latest research has been shown is that the amount of milk in a diet is regulating FTO. And I'm going to try and make it as simple as possible for everyone to understand. You may remember from biology, or you may not. Our genes are like sentences in a book, right? So they are there. They are potential. They have the potential to deliver a message if you open the book and you read what it says, correct? So, but for you to be able to read and understand what the message is, what you have to do, you have to transcribe this gene, meaning this gene has to go from DNA to messenger RNA. Like, so you want to read the message, so it's transcribed. And then after it's transcribed, like you have to rewrite the gene, it has to be translated. Like you cannot understand that, someone needs to translate, it's a different language. So it's transcribed, then it's translated. Then you have the protein, and this protein is what is actually going to have effect on our body. So gene is just potential. Unless a gene is being transcribed and then translated, nothing happens, okay? So, but there's something called methylation, and many people listening to us maybe have heard of. It's not your genetics, it's your epigenetics that is controlling higher risk of disease, for instance. Epigenetic regulation means it's something that goes on top of your genes. And there are many different ways that you can change if this gene can be transcribed and translated. One of the things that can happen is if you have the gene, which is a potential message, if you have a methyl group or methylation come and be on top of the gene, this gene cannot be read anymore. So it would be like you put a physical blockage. It cannot be transcribed. It cannot be translated anymore. Okay, so the FTO gene, as it turns out, he has a cap and protects people from increase the amount of fat in the body and increase BMI. It has this cap. So the more milk we drink, the more we remove this cap. And once the cap is removed, this gene then can be transcribed and translated. So there's molecules called, maybe more complicated, microRNA doesn't matter what they are. But there's one specific called microRNA 29 that does that specific. So you have the FTO gene. The FTO gene is blocked from being expressed, meaning it's there. Is the potential to increase the amount of body fat you have. Is the potential to increase your body mass index. But as long as it has this cap on top of it, nothing's gonna happen. Or the more milk you drink, the more you remove the cap. And now this gene is free to do whatever it wants. And it's gonna be transcribed and translated, and then FTO expression increases, and the more FTO you produces, your body produces, the more body fat you will have. Did I make it, does it make sense at all?
Yeah, no, it makes perfect sense, actually. It makes perfect sense to me. I mean, I also have a scientific brain, and I know a lot of the genes you're talking about. So I think the way that you described it is actually nice and straightforward for people that don't necessarily have a biological background. And that's the key, is that a lot of people living with diabetes haven't been told, haven't been instructed or taught the pathology, not only of insulin resistance and diabetes, but just of, you know, biological regulation in general and how biological systems actually work. So this idea that you can actually arrest gene expression or promote gene expression simply by, you know, changing your lifestyle factors, the food that you eat, the exercise you perform, it's very important. So here's another question.
Can I talk about TOR now?
What's
I just talked about FTO. Can I talk about TOR now?
Yeah, please talk about TOR. mTOR, yes, go for it.
Yeah, mTOR. All right. So mTOR is a molecule that is the main driver of growth in a body. And it has a biological, not meaning, but it's a biological importance, is that when you have a baby, you want the baby to grow as fast as he or she can grow, so that it can reach reproduction age and leave babies behind. Because what we are here to do on this planet, not talking about any spiritual goals, but biological goals, is we are here to guarantee the survival of the species. So biologically, it makes sense that once you have a baby, that baby needs to grow as fast so he or she can grow, to leave more babies behind before something comes and takes you out of the planet, okay? So mTOR then is this one molecule that senses all the cues around us and either promotes this growth or halts the growth. So back in the day, when calories were very scarce, food was not abundant, right? So the cues that the body will get in terms of abundance and type of foods that we will eat would be enough that mTOR would drive growth, but not too fast and not too much, okay? And then on the flip side of it, once you pass your reproduction age, then there's no point in mTOR to continue to drive growth after you already had your babies. mTOR is doing what nobody wants. It's driving aging, and it's driving everything that you don't want, right? So that's why when you talk about chronic diseases, it's usually say it's diseases of aging, but we say diseases of affluence, of course, because we know better. It's related to the food we eat, but it's also the diseases of aging. Why is it that it's all of this is happening, correct? So now we come into a time where there's abundance. We have excess calories, and we have excess calories that are specifically good at driving mTOR, because mTOR has a natural break, and the natural break is the amount of calorie that we have. So if food is scarce, mTOR stops, and then growth stops. That's one of the reasons why many researchers believe we're trying to show why is it the calorie restriction can increase longevity, because once you restrict calories, mTOR is not in overdrive, as we would say. So trying to combine what we just discussed about FTO with mTOR what happens is, I don't want to pick specifically milk, but I'm going to, since I started on milk, I'm going to continue to talk about milk. And it's a good thing, because sometimes when you talk about being plant-based, people say, oh, I'm just going to be vegetarian. Like, I was vegetarian for 20 years. So if there are vegetarians out there listening, I'm not picking on you. I was vegetarian for 20 years, so I understand. The thing is, there's many different ways you can put mTOR in overdrive. So many different ways where you can increase how much mTOR is being expressed and translated, so how much of this gene is being expressed. And when it comes to dairy, so we discussed the FTO is related to the amount of a microRNA that comes in the milk. So we drink the milk, this microRNA is so always stimulating FTO to being expressed. But when it comes to mTOR, there's 3 different mechanisms, and dairy stimulates each one of them. And I'm not even talking about excess calories, because that's a given. Anytime you have a lot of calories, mTOR will be in overdrive. One is leucine, so the amount of brain chain amino, it's a brain chain amino acid. So the more leucine in a food, the more mTOR is going to be expressed. The other is the amount of insulin. There are certain foods that stimulate the production in a body, and there are very few foods that stimulate insulin as much as dairy. Dairy stimulates more insulin production than even like whole wheat pasta or white bread, like refined flour. And the third mechanism is the amount of IGF-1 that either comes with the food or like the body is also stimulated to produce. So dairy hit all 4. So stimulates FTO expression, has a lot of leucine, which indirectly stimulates mTOR. It stimulates insulin, that also is going to stimulate mTOR, and also stimulates IGF-1, which also stimulates mTOR. So you have 4 different ways the milk is always driving growth, always driving increase fat mass, increase body mass, and that's why milk is really tied with obesity, and is really tied also to increased risk of type 2 diabetes.
Okay, this is fascinating. Very important information there, and you certainly have a great command of that. It's a very nuanced, challenging topic. You make it easy to understand, so thank you for doing that. Now, on to one of the $1 million questions, maybe the $1 billion question. In order to minimize your risk for insulin resistance, is there a generally accepted percentage of calories to come from fat? So is there a minimum, is there a maximum? And is it possible to eat too little fat?
Wow, great question. Let me think about it. I know that when it comes to body weight, about 90% of the population would have a specific genetic mutation, a gene called ApoA5, that basically says that the more fat we eat, above 30%, the higher chances to having higher BMI and being overweight. So if we think about type 2 diabetes being also many times, so most of the time related to also accumulation of body fat or people being overweight or obese, then I would say the threshold would be this 30. But the 30 was a number that it wasn't selected based on scientific evidence. It was just like, how about 30%? Let's check 30%. And that's how people went about. There was some research done in terms of amount of sugar in a diet that would be related to increase or decrease weight. But in this specific research, what they did is 2 different groups ate the same amount of fat, same amount of protein, same amount of carbohydrate. The difference is that the carbohydrate change. In one group, 43% of women ate sucrose, so 43% of the carbohydrate was sucrose, was sugar. And the other group, 4%, I believe, was sucrose. And there was no change in the weight. So that research kept fat at 11%. So fat being at 11%, even if you were eating the carbohydrates that we know you're not supposed to be eating, which is pure white table sugar, you did not gain weight. So, and they saw some markers for, I believe they saw some markers, if I'm not mistaken, they looked at cholesterol and some other markers, and they did not change much. It was not significant, the change. So the research shows that in people that have their weight is stable and their diet is low in fat, any increase in fat will increase the amount or the risk of overweight and obesity and increase the risk of type 2 diabetes. So the number would be anywhere between 10, 11, and 30. What is the magic number? I do not know. What I know is from my personal experience and from people around me, if you keep your dietary fat intake below 20% or around 25%, it's going to be very, very hard for you to gain weight. It's going to be very, very hard for your markers to change. But for people that already have disease, like the consensus among Ornish or McDougall is that it has to be below 10% for the reversal. So they keep it around 7%. So I do not know that we have that number set in stone, but the safest bet for someone that has a chronic condition, I would think based on clinical trials that are going on now, we'll know more as we progress, would be safe to be around 10%. For everybody else that wants to prevent, or is it early stages, is pre-diabetic or has high blood sugar, but has not been diagnosed with a chronic condition yet, I would say 20-25% could be safe. So I do not have like a final answer on that.
And that's great. And I've read several of your articles on essential fatty acids, so maybe you can touch on that a little bit and the idea of, can you have too little fat?
Too little fat. I think it's the same goes with too little protein, right? So whole foods come in a perfect package. And if you're eating enough whole plant foods, they are intact and that are allowing you not to lose any weight, I believe you're getting the perfect balance of the amount of fat that you need and the amount of protein that you need. It's like it comes in the perfect package. For instance, you can go with a food that is very low in fat, like beans. Beans are very low in fat, less than 1%. Garbanzo beans are exception, which is 2%. That's why most people love garbanzo bean, because it's like 2 to 3 times more fat than any other beans, and then you have that good feel. That's why people love hummus and all of that. And you can have something that most people think has no fat, which is oats. Oats is 16% fat. So then people eat oatmeal, they have the satiety, they love, and all of this. So as long as you're eating, and you can eat oatmeal with strawberries. Strawberries about 8% fat. So you see, it can be 8% for strawberries, 16% from oats, 1% or 2% from beans. As long as you are eating different foods, you're going to be at least in the 10%. In fact, if you want to keep below 10%, you really have to be careful. And the other thing I should have mentioned before is, if you have oil in your diet, any oils, if you add oils to your diet, it's almost impossible to keep fat below 25%. Just like 1 teaspoon of oil and you're above 30%. So this is one of the things that people say, but no olive oil, no oil whatsoever. And say, it's not just, forget that oils can damage endothelial cells, forget that it's going to make the blood sluggish, forget all of that, that is going to increase the overall amount of fat. Just looking at energy density of oil, any type we add oil to any food, 30% at the end of the day, we're going to be above the threshold. It's almost impossible not to.
Okay, so this is actually one of the more important topics in the world of, insulin resistance in general, is that a lot of people believe that if you're eating a fruit, like a banana example, or some quinoa, that there's no fat, there's zero fat, that it's literally just a ball of sugar, right? Or just a ball of carbohydrate, and that there's nothing else inside of it other than, quote unquote sugar. But what you're saying here is that you can eat a strawberry and 7 to 8% of that strawberry is fatty acids. You can eat oatmeal and 16% of oatmeal is fatty acids, right? So what would you say to someone who, says to you, oh, my doctor told me not to eat fruit. I'm not going to eat fruit because it's just sugar. How do you respond to that kind of thing?
Well, this one it's like any other question or any other answer that I just gave. The thing is, first, the person needs to be willing to hear, right? So when people try to debate you, you can always ask, do you want to understand or you want to debate? I can go either way. Debate, usually I don't go there. If you want to debate, I say, go find somebody else. Because I'm not here to prove anything to anyone, really. There were people that wrote me on Twitter and they say, can you go on this radio show and debate this person? I say, no, I would never do that. I'm here to teach whoever wants to learn, and whoever has a genuine interest in understanding the reasons why something versus the other works. But I will answer your question about fruit. But before, one thing I wanted to mention, anytime we tell people not to eat oils, they say, but we need fat. And I cannot go on a fat-free diet. Fat-free doesn't, it's not something that is good because we need fats. Yeah, we need fats. And oil-free, it's not the same as fat-free. It's impossible for us to go fat-free unless we're not eating any food, because all foods will come with fat. It's whole foods. Some fat will be attached to their food. And if you're eating packaged food, they're going to be adding food. So it's impossible not to go on a fat-free diet. It doesn't exist, right? So specifically about fruit, sugar, it's only problematic for our health if it's added. So it doesn't belong to the food and you're adding extra from a different source. As long as sugar is coming as part of a food, like as part of a whole package, it is, our bodies want that. Our bodies are made to process that sugar. And with fruit, it's not different. So when we talk about high fructose corn syrup, we are talking about fructose that is not attached to any food anymore, doesn't have any fiber to it. So either it came from corn or it can come from, I don't even know the source and it doesn't matter. It's sucrose, it's fructose rather, that is not attached to a food. So it's a liquid. And as long as you're adding sugar, whether it's powder or it's liquid, but it's something that doesn't belong to food, then it's something that you have to be careful about. But even if you do want to add some sugar, the World Health Organization established that as long as it's below 5% of your calorie intake, it should still be okay. Because this is the entire fabric of your diet matters more than small amounts of added sugar that you may have, okay? But fruit will always be fructose that comes with fiber and that comes with all the other nutrients that are present in different types of fruits, so there's no problem. And I've heard this before, like, I'm from Brazil. I love my mangoes. I love my pineapple. And those are the first two foods they say, don't touch a mango, don't touch a pineapple. They're very sweet. Mangoes, then, they don't touch them. And it's ridiculous because or even papaya sometimes, all very, very high in sugar. Yes, natural sugars come with a fiber, and it's perfectly fine for us to eat. If you're eating dry fruit, then if we're discussing calorie density or energy density and the increased risk of, someone being overweight, then when we're talking about dry fruit, we remove the water, then the sugar gets more concentrated. But even dry fruit wouldn't be the culprit of type 2 diabetes. You can put in your oatmeal. Even Dr. McDougall says, if you can sprinkle a little bit of brown sugar, if it's gonna help you eat your oatmeal, do it, right? What is the 5% rule? It would be the equivalent of 1-2 tablespoons of an added sweet, but it has to be for the entire day. If you're eating packaged food that has added sugar that you have no idea how much it is, and in this country, we're very close to being able to see how much added sugar we had in packaged foods, but that is gonna be away for a few years. But if you can't, then avoid packaged foods because you don't know, or you can read the ingredient list. If it says the first 4 or 5 ingredients say sugar, put it back on the shelf where it belongs, and just eat the whole fruit. It has nothing to do with type 2 diabetes. It's not going to cause type 2 diabetes. Just go about your day and eat as much fruit as you want. In fact, there was a publication or research done, and it was funded by the Bill and Melinda Gates Foundation, and they say that lack of fruit intake was directly related to all of the chronic diseases that we see nowadays. So if people would just increase the amount of fruits and vegetables, but they were very specific about fruits, you wouldn't see as many deaths or as many people having type 2 diabetes or cardiovascular disease, cancer, you name it.
Yeah, so this is music to my ears, Dr. Oliveira. Thank you for making all those points. Now, our final question that we're asking our experts is, what is the #1 challenge that you see people face when they make lifestyle changes, and how can you help them overcome those challenges or that specific challenge?
Oh, #1 challenge is between the ears. It's what you believe, always. It's not that you cannot cook. It's are you willing to look for the information, and are you willing to change your beliefs? Because if you're not willing to change your beliefs, there's nothing nobody can do to help, right? So if you believe that something is the way to go, and you're not willing to see differently, it's not willing to change your beliefs, it's really about the belief, right? So let me see if I can give them specific. And the thing is, sometimes, and I'm not saying that calling people stubborn, you're not willing to change your beliefs, but sometimes when we have conflict information, the brain will always do what is the easiest, which is continue with the status quo. So all of the discussion about high fat or high carbohydrate, avoid fat, avoid carbohydrate, if it's confusing, people will continue to eat the way they do. So it's going to be very hard for us to do a job to stop the confusion. So what I can tell people is that if they're confused, all they have to do is read more, read more, read more, read more until you were not confused anymore. Because both sides will always have great points. And if you just sit there and I say, who I'm going to believe, and you don't do your own research, you're going to continue to eat the way you eat. It's going to be very, very hard for you to change. You only change when there's a clear cut. This is the way to go. And I give a personal example. For instance, I throughout my life, I gave up many different foods very easily. Soda was the very first one. My mom said, it's not good for you. And it was convincing enough. There's no, maybe it's good for me. Boom, gone. Then meat, for different reasons. Meat is no good for, I shouldn't eat meat. Gone. Fish. I said, fish gone. Then some time passed. Oh, fish can actually be good for you. Okay, fish come back. Then fish came back. Then I was pescatarian after being vegetarian for many years. No, fish is no good. Fish goes. Now, don't want fish anymore. Then I went plant-based 10 years ago. And within a few months, I'm not going to say who the person was, but it's a very well-known physician said, yes, you can be 100% plant-based, but you may have fish once a week because you still get better omega-3 and this and that. And I said, And then for the first, I'm not kidding, for the first 30 days when I went plant-based, I had fish once a week. Why? Because it was conflicting information. Was the fault of the guy who said, no, the fault is mine. I didn't do my job. I didn't go into the literature and start finding information. So as long as the conflict information was gone, then the path was clear. But it's only up to the person. So one of the great things is whoever is listening now, they are doing their homework, but they're going to leave maybe this conversation and they're going to hear something else. So they have to dig in and they say, is it really true? Why is it that what this other person is saying not true? Let me find out. And you have to. And there's not, you and I, we can give the seed and we can talk as much as we want about why this is a better way to eat. But as long as the person is not willing to go and dig themselves, they will always have this conflicting information, and conflict beliefs will never allow you to move forward.
Yeah, I couldn't agree with you more, actually. I think, you have a wealth of experience. You got over 20 years of experience in research, in the academic setting, and then also, with your own personal diet. And I love the fact that not only do you research this, but you practice it yourself. So I can't wait for the day when you and I get to sit down and either eat some acai together or have some mangoes together, because I know you love both of those and I do too. And thank you so much for your time today. We really appreciate you being here and sharing your insights, because I know it's going to change the way a lot of people think.
Oh, my pleasure. Good luck and keep spreading the good word. And more people need to learn about it. So what you're doing is beautiful. Just keep it up.